All right, welcome back. Here we are with the final lesson in this first unit, statistical reasoning in everyday life. Yes, statistics. I actually like statistics. I actually teach statistics. Now, don't be scared because this is very simple and very fun and very applicable statistics because this is really this is really going to give you an overview of why you need that math class, which is usually going to be like a college entry statistics class or like AP stats in high school. But it's really motivating to take it and understand how it's applied in psych. So let's go through it, and I'm going to try to give you as many examples and simplify it as best as possible because it's cool. And that's not just me saying it, because this is actually how I really got into like statistics, descriptive statistics. So let's go over first. Ironically, our first term is going to be descriptive statistics. This is basically like what most people think of when we hear stats. What are stats? Like your height, your weight, sleep, hours of sleep, or amount of sleep. And more specifically, in terms of what type of stats we would use for this stuff, usually it would be like mean, median, mode, those common ones. But there's a whole bunch of other statistics than just these three, but these are usually the first ones you'll learn in like middle school or something. Now, let's think of an example. Let's say you want to figure out how. Well, I mean, I always wonder like how much time students spend on their cell phone each day. We can use what's called a histogram to graph this data. Histogram, and this is basically like a bar graph, but it's numerical on a continuous scale. So if you're measuring hours each day, or time spent on a cell phone each day versus hours of sleep, let's say, or maybe GPA. Well, let's just go hours of sleep, like amount of hours of sleep. So hours of sleep on the vertical axis versus hours spent on cell phone each day. You would want to break this up into groups, intervals. So let's say the first group is from 0 to 1. Let me actually use red. 0 to 1, the next group is 0 to 2, or 2 to 1, or 1 to 2, or more than 1, or sorry, from 0 but less than 1, 1 but less than 2, 3 but less than 4. Maybe you break it down by hours. And so forth. So then over here you would also have hours. 1, 2, 3, 4. So maybe it looks something like this. This is an example. Now, you don't have to color them in. I don't actually want to waste my marker. But I wish I drew that a little bit better. But a histogram is continuous, meaning that all the time gaps have to be there, meaning that you can't skip like a time between 2 and 3 hours and 4 or 5 hours. You have to make sure it runs on a continuum from 0 to whatever your max is. This is different as opposed to like, let's say a discrete graph or a bar graph where it would be like how many how many pets do you have? It could be like 0, 1, 2, 3, 4, and you would have gaps between them. No gaps here. So one thing you have to make sure you understand, or the main thing that I think students will miss on this stuff, is understanding how the intervals work. So typically it'll be what we call a left-handed interval. So this first interval will be 0, but 0 to less than 1. Let's see, I don't know how I would write it. Well, technically in a math way, you would include 0. Let's say it's x, but less than 1. Here you would include 1, but not 2. Here you would include 2, but not 3. Here you would include 3 and not 4, and so forth. So here you would be like 6, but don't include 7. 6, but not 7. Be careful about that, because if you don't pay attention to that, you can double count. Meaning you may include 6 twice, or 7 twice, or whatever, 3 or 4 twice, and it's typically left-handed. So typically we go from like the left side, 0 is included, 1 is included here, 2 is included here, 3, 4, 5, 6. That's really the main thing you want to make sure you don't mess up. That's the most common mistake I've seen, because I've taught math. I mainly teach math. I only teach one psych class. So let me get some water. So that's my tip for you guys. All right, let's keep on going. Okay, so like the mean, median, mode are common statistics that we've used. I don't think I have to write these, but just remember the mode is the most commonly occurring number. So let's say like there are more, let's say that you had a set of data where everyone had their number of pets. The number, like if the most popular number was 2, then the mode would be 2. The mean would be the average, arithmetic average. Mean will be, let's say, we usually use x bar, mean x bar. Let me just write this formally. Mode most. And median middle. So let's say we have number of pets, 1, 2, 3, 4, 5. You had 1, 2, 3 at 0, 1, 2, 3, 4 at 1, 1, 2, 3, 4, 5, 6, 7 at 2, 1, 1, 2, and then maybe you had a gap and 1 there. So the mean, you would add all these values up. We add all these values up, 0 plus 0 plus 0 plus all the way to 6. And you divide by the total number of values. 3, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And whatever number you get would be the mean. Also, I don't think you really even have to be super, like, you have to know these things by heart, but we will use lowercase n to represent the number of data points in a sample group. In this case, it would be 18, right? 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah. The mean you would divide by the number of data points, so we write this as formally as x1 plus x2, all the way to x18 divided by 18. The mode would be 7. And the median would be, think of a ranking when you have median. What value would be in the middle if it was like a race? So since 18 is an even number, 9 and 9. So the first 9, 3, 6, 7, 8, 9. The median would be in here. Since they're both the same, the median would just be 2. Think about ranking. Again, like if you were a race. Like if you had 18 people running in a race, whoever came between 9th and 10th place. Yeah. that's pretty much all you really need to understand about that, but I'll go through examples when we at the end of the chapter. Percentile. Percentile is basically like your ranking in percentage. So like we're, let's say the 10th percentile. 10th percentile, we would say. Let me use well, we would write it like this, I guess. Actually, no, let's do 25 percentile. 25th percentile. So you want to figure out which value has 25% of the data points below it. Now, 18 divided by 4 would be 4.5. So it doesn't go evenly because there is no 4.5 value. So you would round it, you would be conservative, and 25th percentile would be the first 4 values. So this would be the 25th percentile. So this would be equal to 1. So in other words, the value in the data set that has that percent of the number of subjects below it or below it. If you're at the 50th percentile, what value has half of the data points below it? So we're looking for the 9th value. 3, 6, 7, 8, 9. It will be right here. It'd be 2 again. And again, I'll go through examples at the end of this unit when we go over some practice problems. Skewed distribution, when you have like a tail. So when you have like a graph that has like a tail. Actually, let me go back and erase this now. So let me talk about like the types of shapes you'll usually see. Shapes, so we have symmetric, which will be something like this. So it's like mirror images through the center of it. And we're going to go over the normal curve in just a minute. But you know, even on both sides. Skewed, we can have 2 different ways. Skewed right would be like a tail like this. And skewed left would be the other way. Here I go. Think about like the way I have students remember is like if you're going to go skiing or snowboarding or whatever, or on a ramp, which way would you go down? This would be like the downhill. I mean, unless you're hardcore, but they're not going to usually have it like this. But skewed left, wherever the tail is heading towards, skewed right in this one. And there are like, you know, value, or there are very common statistics in the real world where the data will be skewed right. This will usually be like income or something like that. Income is usually one of them. College, like tuition, real estate price, home prices, that sort of thing. Meaning that a very small percentage of the entire population is much larger than the rest. All right, now let's look at a couple other. The range, standard deviation, and normal curve. Let me think of an example I can use for these. Think of an example that you guys like to know about, or think of like a real life question that you may want to know. You would use statistics to find out. So let's say, I have this is a normal curve. Also, it's also known as like a bell curve. It's very popular. It's the most popular curve in all of statistics. It gets all the attention because it occurs so common in like many phenomenon or many things that occur in the real world that we actually use. So let me break it down. So it's going to be symmetric, and if you go deeper into statistics, we'll notate it like n sub mu or n sub mu and standard deviation. But don't worry about that right now. If you're in a statistics class, I like to add this. I also teach statistics, so be sure to catch those videos. I'm going to be updating them to make sure you know your stuff. So a common normal curve is height. It's like male height, let's say. And here is going to be the mean male height. It'll be centered at the mean. And the mean male height that I can recall the last time I checked was 5'9" in the US at least. 5'9". The standard deviation, which we use this for, let me just write it like this. Standard deviation is, I believe, 2.5 inches. And so let me write this on. Actually, I don't know what I'm doing. Actually, I wrote it out. So this stands for standard deviation, and let me just draw an arrow up here so we can refer to it. This is all improv. I just decided to pop up my book and crank this video out and see if I can do it on the fly. So I apologize if it's disorganized, but it shouldn't be that hard to understand, hopefully. Okay, so standard deviation of the male population of the population of male heights in the U.S. is 2.5 inches. All right, yeah, let me just write it. Yeah, inches. Has a mean of 5'9" inches, and it follows a normal distribution. A normal distribution has various properties. I don't know. You're going to need to know just a couple of them, but it follows a 68, 95, 997 rule. So the way it's broken down is that 68% of the data is within one standard deviation of the mean. 95% is within 2 standard deviations. And pretty much all of it, or 99.97%, is within 3 standard deviations. So let's go like this. So again, 1 standard deviation, 2 standard deviations for 95, 3 standard deviations for 99.7%. What that means is that if we know a distribution's mean and standard deviation, given that it's normal, we can pretty much figure out, we can calculate all these statistics and probabilities about what's the chance that you'll be above this height or below this height, between these heights, because these are just calculations based on a couple of statistics. So for example, this means if 68% of them are between, or if 68% of the data of male height is between 1 standard deviation, that means that 68% are from 5'9" plus minus 2.5 inches. which is going to give us an interval of 5'6.5", right? 5'6.5" inches to 5'11.5" inches. Where'd my red go? The 95% says 2 standard deviations. So we take 5'9" and add and subtract 2 times 2.5 inches, which is essentially adding and subtracting 5 inches to 5'9". Well, here I am, which gives us 5'4" to 6'1" inches. And I just realized I should have, no, sorry, 6'2". I should have just put this in just straight up inches instead of feet and inches, but it's okay. That was my knee. And 99%, almost 100%, or 99.7% of the male height in the US, 99.7% of male heights in the US are within 3 standard deviations of the mean. So 5'9" plus minus 3 times 2.5 inches. So subtract another 2.5 inches, so 1.5 inches to 6'4.5" inches. And again, we'll do practice problems if this can be a little like confusing. But if you can get that, that's like pretty good, because I'm pretty much just doing all the math that you'll need to know for this course in terms of just the statistics. Now, again, if you're in a statistics class and then when you guys go into real psychology courses where you have to do research, you're gonna have to do calculations, but you won't have to do like the tedious part. You'll just have to know like what to plug into usually some computer software. Now let's talk a little bit about standard deviation, because it tends to confuse some students more than it should. So don't overthink it. So think of like what mean means, or average. Average is a measure that tells you about the middle of a set of values. Standard deviation is a measure of spread, how spread out a set of values are. The standard deviation of the male heights is 2.5 inches. So it's going to tell you that 2.5 inches is going to let you understand a measure of the distribution, but it's more about comparing. So for example, for female heights, the mean is, I believe, like 5'4", 5'3". We'll just say 5'4". And the standard deviation is, I think, 2 inches. And this could be maybe 3 inches, but don't worry about that, because this is just an example. It changes, but right now you want to understand that if the standard deviation of female height is 2 inches, this means that the female height distribution is less spread out. It's centered at 5'4", but 68% of it, let's actually do red. %, within 1 standard deviation, meaning that you would go from 5'2" to 5'6". But just the fact that the standard deviation of female heights is less than standard deviation of male heights tells you that it's more compact, it's less spread out. If it was like 6 inches, it would be more spread out. Even though the center is lower, standard deviation gives you a measure of spread. So like, for example, let's say I have my classes take a test, and the mean of one class is like, let's just say mean of one class is 75 or something. And the other mean is like 85. But the class has a mean of 75, has a standard deviation of like 15 or something. Whereas the class that has, let's say, plus minus 15, whereas the class that has a mean of 85 only has standard deviation of 5. So this class is less spread out. There's less variability in the set of scores for this class, and this class has much more variability. Again, I will do practice problems because I love math and statistics. So make sure you watch those, and I'll link them to this video once I get them done. And the last definition dealing with stats is just the range. The range is just, this is very simple. It's just, again, another statistic from the value, the number or the value that tells you the distance from the lowest to highest value. So we can say distance from minimum to max. Minimum to max value. So like maybe, I think for like the pet example, it was like 0 to 6. The range would be 6. I mean, if test scores, so if the lowest score was 15 and the highest was 91, then the range would be, what is that, 76. Simple math, hopefully. And okay, last couple of important terms. When we're talking about statistics, and when we're trying to conduct studies in psychology, let's say we're trying to figure out how much social media affects a student's depression. So let's say social media. I know I'm always talking about this stuff because it's a big thing I'm noticing in these last few years. So social media time versus depression scores. From studying this, I would record how much time my students or whoever, my group, spends on social media each day and what their depression scores are. Now, let's say if I find a trend where, let's say, let me write social media, depression scores. I find a pattern where as social media time goes up, depression score increases. More social media time each day, the more depressed the kids are in the study. So we can then say, oh, social media is positively correlated with depression. The thing we have to remember, though, is we only took a sample. We can't obviously record every single person in the world because it would just take forever and it's just impossible. So what we do in statistics, that's what statistics are. Statistics are data on part of the entire population, which in this case we want to figure out how social media affects all the teenagers in high school, let's say in California or in the US. We maybe take a sample at a couple schools or something, and from there we make inferences to the large population. We infer like, okay, based on this data, it seems like this is that social media does result or cause you to be more depressed. That's what we have to do. That's kind of the goal in inferential statistics, is to be able to take samples and apply our analysis to the entire population that we want to study. And this is where it gets complicated because there's always a chance that the group we study has just has data that doesn't really actually represent the true population because it was just due to chance. Meaning that maybe we just got a group of students that just happen to be more depressed, regardless of their social media. It's possible, so we have to keep that in mind, and this is why it's always better to do bigger studies. And you probably heard of meta-analysis and thought it was a complicated word, but it's really not. It's a cool word. It just means that you're going to be taking big studies across multiple groups, across multiple subgroups, across time. The more information, the better. Ultimately, we want to get to a point where our data is statistically significant. We want to have data where we can say, okay, based on our inference methods and our statistical analysis, yeah, we can always say that the result could be due to chance, but the results are so powerful or so large or so unlikely to occur by chance that they are what we say statistically significant, and then that's what allows us to say, okay, we can then apply these to the rest of the population. We want statistical significance, meaning that the results are so are very, very unlikely to occur based on just chance. That's ultimately the goal. Meaning that, like, for example, let's say someone says, I can guess what if you're flipping a coin, I bet I can guess what the coin is going to land on, no matter how many times you flip it. You flip it once, they can get lucky. They say, oh, heads. Flip it twice, they can get lucky. 3, 4, 5. But if you flip it 1,000 times, the chance that they're going to get all of them right is 1/2 to the 1,000th power. So if they get 1,000, correct guesses, you're probably going to say this is so unlikely to occur to chance. I think the results are just like, let me see. It wouldn't even register on, it would be like pretty much 0. Point. Whoa. Yeah, it's going to be essentially 0. Since the probability of them guessing 1,000 correct coin flips in a row is pretty much 0, we can say, okay, yeah, this guy probably does have some magic powers. And that's when we say, like, okay, we have statistical significance, and our study is going to be pretty that's reliable. And last term, before I end this video, we have effect size. Let's say you are trying to study for the SAT, and you hire a very expensive tutor, and you want to obviously you want the tutor to improve your score. Let's say you've been getting an average of 1310, and he's like, I'm guaranteed that I'm gonna help increase your score, blah blah blah, and he ends up increasing your score, but only to like 1315. But he can show, and we can confirm that it is due to him and not due to chance, but the effect size is so small and weak, like who gives a crap? He only improves the score by 5 points, not worth paying all that extra money. Technically, again, it's because of him, but we have to consider, like, is this worth it? A common scam, I say, well, not really a scam, but something to keep in mind, like Band-Aids. Like, they found that if you have a cut and you're gonna use a Neosporin or some antibiotic to help speed up the healing, it does actually work, but it speeds up the healing by, like, I think like a fraction of like a day, like maybe like 10th or 20th of a day where it doesn't really matter. It's like, who cares? What's the point of doing that if it's gonna heal that same amount in just an extra like hour, if I just didn't get Band-Aids or something like that. So consider effect size always. And there you go. I hope that helps. Let me know if you have any questions. Feedback is always helpful. This is a random on the fly improv video. And make sure you subscribe if you haven't yet, and comment and like, and I'll see you guys in the next video.